Hello, everyone. So thanks for coming to this session on Kubernetes native JHipster microservices. I think you have had a lot of Kubernetes today, so sorry about that if you are doing a bit of an overdose of Kubernetes. But I will try to bring some fresh view on this. So first, let me introduce myself. So my name is Pierre Besson. I work as a site reliability engineer at Liquidshare, and I'm coming to Voxday's microservice this year again. So this is the picture of me last year in the exact same room. I'm a full-stack developer, and I'm starting to work DevOps full-time. And also, I'm a core team member of the JHipster project. And JHipster is actually a very good project to combine a bit this full-stack aspect and extend it into the DevOps. So we will see what I mean by that. First, a word about Liquidshare, which is sponsoring me for this talk. So Liquidshare is a fintech startup funded by major European financial institutions. And at Liquidshare, we want to simplify the way trades are settled on the stock market. And for that, we're using blockchain technologies. So our tech stack is composed of a Spring Boot-based microservice architecture using Kafka and gRPC, and a private permission blockchain based on Ethereum. And we're also running a fully automated Kubernetes infrastructure with Istio and so on. Quickly, a word on JHipster. So I think many of you already know, but JHipster is a code generator. We provide a scaffolding for a full-stack application with a Java backend using Spring Boot and a JavaScript front-end, TypeScript, with a choice of the major frameworks, Angular, React, and Vue.js. So what we strive to do with JHipster is to implement the best practices from each technology. So the goal is not to generate a Hello World application, it's to generate a full application with all the best practices in place. And we also want to maximize developer productivity and set up all the tooling for you. So it can be hot reloading of the front end. It can be developer tools for the back end. And we also want to provide an app that is production ready. And of course, we support not only monolithic applications, but microservices as well. So what do we mean by microservice support for JHipster? So of course, JHipster lets you generate a microservice, which is a Spring Boot app with a REST API and access to the database. So we automatically generate the required code to connect to a database, and we support most of them, PostgreSQL, MongoDB, Cassandra, and Couchbase, I think, and a lot more. We also let you generate JHipster gateways, which are applications that provide API management, and that will also aggregate all your microservice APIs and expose them, for example, through a Swagger, aggregated Swagger portal. We also generate CI/CD pipelines. So if you have a JHipster app, you can automatically generate its CI/CD pipeline for Jenkins, Travis, GitLab CI, and more. Then we provide a way to locally test the integration of all your JHipster microservices. So we can generate Docker Compose files, and also deployment files for Kubernetes. And this is what we are going to dig more into today. So a small intro on Kubernetes, which, as I think all of you know, is today the almost de facto way to run Docker in production. So what is Kubernetes? Kubernetes is a container orchestrator, which means it can schedule containers on multiple hosts. But what's very important to understand about Kubernetes is that it only schedules containers, not applications. It is fundamentally a low-level platform. It is not a platform as a service. It only understands containers. You need to think about it as a distributed OS, like Linux for containers. but not a platform that will do some magic to deploy your apps into. So what does Kubernetes provide? It provides virtual networking through, for example, the pod object. So a pod will provide you a virtual IP for a bunch of containers. And also in the pod, you will have access to internal DNS so that applications can find each other. Kubernetes will also offer basic load balancing through the service object. So it used to be a round-robin load balancer, but I've just checked, so that's why I've struck through a round-robin. Right now, Kubernetes provides a random selection algorithm for load balancing. But once again, it's very basic. It also provides configuration facilities through the config map and storage, so you can attach volumes to your containers. So how does Kubernetes works? In Kubernetes, everything works thanks to controllers. What is a controller? So basically, a controller is a service which regulates the state of your cluster, continuously regulates this state in order to realize desired state. So I tell Kubernetes I want to schedule some containers. Kubernetes look at the state of the clusters. It sees the containers are not there. It looks at the desired state, and it does the reconciliation between desired state and actual state. For that, Kubernetes relies on a highly consistent database, which is etcd, and it can receive CRUD operations: create, read, update, delete. Those operations act on Kubernetes resources. Those resources are defined usually from YAML files, but you don't have to use YAML files. You can do it programmatically with the REST API, gRPC API that is provided by the Kubernetes API. And some examples of these resources are the pod, which is a set of containers scheduled on the same host. The replica set, a set of identical pods. Deployments, the state used to do rolling upgrades of replica sets. A service, which is a network service to expose a set of pods. And the ingress, which is a route from outside of your cluster into your cluster. Then, starting from those constructs of Kubernetes, some people thought this is not enough, and so they want to extend it. And this is why we say Kubernetes is an extensible platform. And what those extensions consist in are operators. And operators, they are controllers, like the deployment controllers, etc. But they are custom controllers based on custom Kubernetes resources, which means not just the base Kubernetes resources like pod, deployments, some custom ones. So to give you an example, there is a project called Cert Manager, which implements such operators. So Cert Manager can provision for you TLS certificates from Let's Encrypt. So you will tell the Cert Manager, I want a Let's Encrypt certificate for this domain, and it will automatically do the requisite challenge to Let's Encrypt to obtain this certificate, and then store the certificate in a Kubernetes secret. And then you also have the service mesh, and a service mesh, to define it simply, it's a set of infrastructure service that implements microservice patterns. So what do we mean about microservice patterns? Basically, what this conference is all about, which are the basic requirements you need in a microservice architecture to be successful. And this encompasses service discovery, API gateway, data consistency, inter-service communication, scaling, observability, etc. So to achieve this, we think you need a microservice platform, and that's why JHipster supports 2 microservices platform. So the first one that we historically support is Spring Cloud. Spring Cloud is a framework-based platform, which is actually an extension of Spring Boot. It's implemented as embedded libraries into your apps, and those libraries actually provide the interceptors to implement things like circuit breakers, service discovery inside your application. And of course, it has some limitations. It supports only Java. And on the opposite, Istio is a completely different approach to such a platform. It is based on infrastructure microservices, so which are deployed into, for example, a Kubernetes cluster. It's implemented as a service mesh through sidecard proxies. I will explain a bit later what else do sidecard proxies. But fundamentally, as it's not inside your app, it can support any languages. And so it can support microservices written in any language. And there are a few other aspects that are interesting to consider when comparing those technologies. So for example, the deployment, overhead, and the ease of troubleshooting. So Istio is support in the JHipster project. We have looked into Istio since almost the beginning of when this technology appears. But as of right now, it's still a work in progress on our part. It can provide many solutions to the prime concerns like resiliency, API gateway, traffic management, security, observability. Just a quick note on the sidecar mechanism. So how does it work is that Istio will deploy proxy services next to every instance of every microservice. So which means when service A wants to call service B, it has to the request has to go through the service A's sidecar, and service A's sidecar will call service B, which will be again intercepted by the proxy of service B. And so which means that all the concerns like load balancing, circuit breakers, and so on are completely handled by the proxy. And then Istio is able to orchestrate those proxies independently from your apps. So let's go on with the demo. So I have a provision Kubernetes cluster for this demo. So this one is running in Google Cloud, but it could run. The demo could work the same in every platform. I have also installed Istio into my system. So you see, we have a bunch of Istio services running in the Istio system namespace. And I have also installed JHipster in its latest version. So the demo we are going to do today, I'm starting from scratch. So I've prepared the JDL file. The JDL is our domain-specific language to describe JHipster applications. So I've described two applications, a store application, which is of type gateway, which uses JWT as authentication. Its database is MySQL, and it's using Maven as build tool and Angular as the front end. The other application is a pure microservice, only the back end. It's called Accountancy. It's using MongoDB. And I've defined a bunch of entities on those microservices. So those are the entities that will be generated into the apps. So I have I have product entities, customer entities for the store application, and I have an invoice entity for the accountancy application. And once I have defined my applications and my entities, I can define deployments configuration. And with this, JHipster will be able to generate the appropriate YAML files to deploy my application. So I have, for example, on the top, I have a deployment for Docker Compose. So this is to locally test the Docker containers on my machine, and also for Kubernetes. And you notice that I have enabled Istio. So I am going to simply run JHipster import JDL to import this JDL. And what is going to start is JHipster is going to generate all the files for my applications, and also the deployment files for Kubernetes. So here you have all the files. So if you have the accountancy application with its pom.xml, but we don't have the time to dig into the actual code. So I have pre-built the images and pushed them to Docker registry before this demo. What I'm going to do right now, because we are constrained with time, I will run this script that is generated for you to deploy all the resources to Kubernetes directly. So you see this script is very simple. It's simply to apply the YAML files that I've generated to my cluster. And while you see here that it's, sorry. You see that my deployments are initializing and are getting deployed to the cluster, which is really fast, but still it takes some time. So during the time it's trying to deploy, let's have a look to some files that were generated for me. So here you have a simple deployment configuration. And so if you are not very familiar to how to read this kind of files, let's go through together. So this is the Kubernetes object that we are defining, and some of the metadata. The metadata are used to find them in the cluster, to classify them. And here you have the spec. Spec is really important. The first spec defines the deployment spec. So here I have a deployment object. Under it, I have the deployment spec. In this deployment spec, I specify the number of replicas, which means the number of instances of this deployment, of the containers in this deployment. The selectors are the way to match the deployment with its related pods that are controlled by this deployment. And the second spec is actually a pod spec, which defines a pod. And in the pod, you have a list of containers. As we said, a pod is a set of containers running on one host. So here I have only one container, which is my store. I have here the Docker image. For you, it should look more like something like this, because you should always specify a Docker tag when you use such kind of configuration. And then we define some environment variables. So the prod profile is active. Here we have Kubernetes. We have a secret, which is used for the JWT authentication. So if you want to see, this is this one, and this is this is imported into my deployment. And here we specify the data source URL, and so you have the URL of your MySQL database. So we generate a MySQL deployment. However, it is only for demo purpose. It is not recommended to run a database in Kubernetes yourself. It's very tricky to do so. But right now, it will help us get started. A very important part of this configuration is the resource request and limits. I will speak only about the limits because this is the most important. So basically, Kubernetes is a scheduler. But to efficiently schedule your containers, it needs to know how much resource does your container need. And so this is why you need to specify a limit. So here I specified that my container will use only one CPU and 1 gigabytes of RAM. So what will happen if its usage is going up and passes one CPU? If it passes one CPU, Kubernetes will throttle my process. So it will start getting really slow. But it's still working. However, if the memory usage goes over 1 gigabyte, Kubernetes will simply kill your container. And you also have the readiness probe and the liveness probe. Those are very important. The readiness probe is used to know when your application is up, and as soon as this endpoint answers OK, Kubernetes will start routing traffic to your container. And the liveness probes is to know if your app is still alive. If it's not alive, Kubernetes will happily kill it. So that's it for the deployment files. So this is the deployment file is a part of Kubernetes native resources. However, the gateway is specific to Istio. And with this gateway, we define an endpoint into our cluster. And so this should have deployed fine. And so if I go to this URL, I will be able to see my application running. So I will very quickly check that everything is OK. So I'm logging in. And I will create a sample product. And so here it's created. So now I know that my store application is working correctly. And I also you have another entity, the invoice, which is on the other microservice. And I will check that everything works fine. And it worked. So now, because I have Istio, remember I have this sidecar everywhere that is intermediating all my communication. So I will be able to observe this with Istio and with the observability stack that is offered by Istio. So for example, you have Kiali, which is an observability dashboard for your Istio mesh. And here you can see that I have my JHipster application. So I have my 4 applications running. So the accountancy MongoDB database, the store, and the MySQL database for the store. And I'm able to see a graph of my applications. Can you see it well? Sorry. So basically, I am able to. I will scroll down. Sorry. Sorry if it's a bit, if you cannot see well. So basically, you can see the traffic going in your both applications. So both the accountancy application and the store application, and everything is green. Istio is also able to find some metrics. So, for example, if I click on my app, I will be able to see metrics. So, for example, the requests, maybe like this. Yeah, I can see, for example, the traffic received. Here I have done only 1 request, so not too much to see. Besides Kiali, you will also have other tools like Zipkin. So let's do a search. No. I will go back to the beginning. Yeah. So let me go back to okay. This UI I'm more familiar. So for example, you can see you can understand the requests that are passing into your system. So for example, here you have you can see the request going first into the Istio ingress gateway and then into my store, and see the time it took for both of them. And here I can dig into to see more details about the requests. So you also have access to a Grafana, to a graph matrix, to know about a bit more about how your applications are behaving. However, something I want to point out is that all the observability that Istio gives you is some kind of black box. It is outside of your application. If you want metrics from inside your application, you will have to use other tools. So we are now arriving at our conclusion. So thank you a lot for your attention. We still have 40 seconds for questions if you want. Thank you.